With a mass 66 billion times greater than that of the Sun, it's poised to devour stars, planets, and even light if they dare to come close. It possesses a colossal accretion disk capable of illuminating an entire corner of the universe. Ton 618 is undeniably a giant monster, a machine of destruction in the galaxy. The question here is, before collapsing into a black hole, was Ton 618 once a supergiant star? If it was a star, how powerful would it have been? To answer this question, let's analyze it with Adventure Universe. To give you an idea of what it looks like, let me briefly introduce it so everyone can understand. Ton 618 is the name of a superquasar located about 10.4 billion light-years from Earth. Yes, you heard that right, 10.4 billion light-years. That's such an immense distance that you'd need a super bright flashlight and a space ruler to measure it. But what really makes this quasar stand out is the supermassive black hole at its center. This isn't just any black hole. It's an oversized one that devours all matter at a terrifying speed, without ever stopping. Due to the black hole consuming matter at such a terrifying speed, it occasionally chokes because it can't process everything at once. This choking results in the emission of an enormous amount of electromagnetic radiation, so vast that it defies human imagination. To give you some perspective, the brightness of a quasar can be thousands of times greater than the entire Milky Way galaxy, where you're sitting and watching this video. That's right, if you thought the light from the stars in our galaxy was bright enough, quasars are thousands of times brighter. It's like comparing the light of a small flashlight to a blinding storm of light from a space supercar's headlights. That's why we call it a quasi-stellar object, or quasar for short, because it's so bright, you need super cosmic sunglasses just to look directly at it. But don't be quick to think that all quasars are the same, because Ton 618 is far from ordinary. Ton 618 harbors a supermassive black hole at its center, one that astronomers have described using the most grandiose terms such as cosmic light generator, quasar's peak, or universe shrinker. This black hole has a mass up to 66 billion times that of the Sun and a diameter of 390 million kilometers, equivalent to 43 times the distance from the Sun to the farthest planet in our solar system, Neptune. Imagine the terror of this black hole king. Our galaxy contains about 1,004,000 billion stars, and if you combine all their masses, you get around 64 billion times the mass of the Sun. Yet, that's still about 2 billion times less than the mass of this black hole. If you think that's a staggering number, remember that it's 15,300 times larger than the supermassive black hole Sagittarius at the center of our galaxy. When faced with the enormous power of Ton 618, scientists had to devise a special classification for it. They created a new category called Ultramassive Black Holes. Imagine Ton 618 as a famous rock star, with other black holes as indie bands. This new catalog ensures that Ton 618 is always the brightest star in the black hole sky, not competing with less prominent names. This classification honors Ton 618 with its own pedestal, keeping it at the peak and ensuring it doesn't have to share the spotlight with less prominent black holes in the universe. Returning to the previous hypothesis, there is indeed a type of black hole born from stars. To clarify, according to hypotheses, there are actually two ways black holes can form from stars. The first type is stellar black holes. These are born from giant stars with a mass about 8 times that of the Sun. When such a star runs out of nuclear fuel in its core, it can no longer sustain the fusion reaction, causing a sharp drop in heat pressure and failing to resist its own gravity. As a result, the star's core collapses, creating a shock wave that spreads outward and causes the outer layers to explode in a supernova, forming a cloud of dust and gas. If the star's core is massive enough, usually about 3 times the mass of the Sun, it will continue to contract under its own gravity, forming a black hole. The second type is the black hole star, also known as a quasi-star. As the name suggests, A black hole star is a hypothetical star that contains a black hole at its center. It might sound fictional, but according to Wikipedia, black hole stars are formed when the core of a young star collapses into a black hole. During this process, the star's outer layers are large enough to absorb the energy from the explosion without being destroyed. Such a star would need to be at least 1,000 times the mass of the Sun. To explain it simply, the star's immense mass and the heavy core of the young star cause it to continuously absorb mass from the surrounding gas accretion disk, leading to its collapse into a black hole. However, the thick and massive outer shell of the star absorbs the explosion and remains unharmed. That's my understanding of it. What do you think? Please leave your comments in the section below this video. According to Wikipedia, after formation, the black hole continuously consumes material from the parent star. The black hole's intense gravity pulls layers of matter inward, and the energy released from this process establishes a state of equilibrium. This equilibrium helps keep the black hole stable, similar to how gravity and energy from nuclear fusion maintain balance in modern stars. Due to their insatiable appetite, a quasi-star has a maximum lifespan of 7 million years, with its mass increasing to about 1,000 to 10,000 times that of the Sun. Once the shell is depleted, the black hole star transitions into a true black hole and is classified as an intermediate mass black hole. Scientists believe that these intermediate mass black holes are the precursors to the supermassive black holes we observe today. The surface temperature of a quasi-star is quite fascinating. These stars have extremely high surface temperatures, estimated between 10,000 and 20,000 Kelvin. This causes the black hole star to emit vast amounts of powerful radiation in the ultraviolet and visible light spectrum. However, because its core is a black hole, the temperature and energy emitted can be much higher, making its light comparable to that of a small galaxy. Scientists estimate that the diameter of a quasi-star is about 10 million times that of the Sun, making it roughly 14,374 times larger. For comparison, consider the following. This is our Sun. Our 13601 has a diameter about 35 times that of the Sun. Rigel is 78 times larger. The Pistol star is about 150 to 200 times larger. V Betelgeuse is 1,000 times larger. Vi Canis Majoris is about 1,500 times larger. And the largest known star, Stephenson 2-18, has a diameter approximately 2,150 times that of the Sun. And then there is the black hole star. Wow! Returning to the topic, currently, scientists still do not know the origin of black holes, especially those that are millions to billions of times more massive than the Sun. Some believe that the supermassive black holes we observe today were formed through colossal mergers. These billion-dollar cosmic mergers created enormous cosmic monsters that endlessly devour matter and dominate entire regions of space around them. It cannot be denied that Ton 618 is similar to other renowned supermassive black holes, except that it is a slightly more special black hole. Like a powerful monarch, it reigns at the center of its galaxy. However, observing the galaxy that contains Ton 618 is not easy. The reason? The light from this supermassive black hole is so intense that it eclipses all the surrounding stars. To put it in perspective, imagine that Ton 618 is 140 trillion times brighter than the Sun. It's no exaggeration to say that it truly stands out in the universe. You've just finished watching the theory about the formation of Ton 618 presented by Adventure Universe. What would you like Adventure Universe to cover next? Please leave your suggestions in the comments section of the video. And now, goodbye and see you in the next videos.